All righty. Hello, everyone, and welcome to our NARST webinar. My name is Gerhard Sonnet, and I am the co-PI of the NSF-supported project named Preservice Teachers Assessment of Science Knowledge, which we have been running here from the Science Education Department at the Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts. Two excellent members of our research team will lead you through this seminar. First, there is Cindy Crockett, who will give you an overview over the sampling and recruitment, which in itself was not a mean feat. And then our postdoctoral fellow, Rongzhou Wu, will present what I think are some of the more interesting findings. The project itself has had several outcome variables, but Dr. Wu will concentrate on one of them, pre-service teacher science teacher identity, and how high school and college experiences shape it. I hope you will find these results useful in your own research or in your practical work. That's all from me. Cindy, take it away. Cindy, you're muted.
Cindy, you're muted.
Sorry about that. I thought I had undone that. So Ranju, if you want to advance the slide, please. And we want to thank everybody for attending today. We can take questions in the chat, but we'll save the bulk of them till the end because Ranju has a lot of interesting things to present. So if people would just remain muted. As Gerhard mentioned, as you heard, we are recording this and it will be posted to the NARST YouTube channel after we get that link. So next slide, Ranju. Thank you. So just quickly, what the project was about, we today are going to be presenting a brief overview of our study on pre-service teachers' assessment of science knowledge, which we actually call PTS. And more important, we are presenting our findings on what factors affect pre-service teachers' science teacher identity. The next slide. So we're looking for a couple of outcomes here. One, who is currently being prepared to teach science in K-12? Secondly, when and how does pre-service teachers' science knowledge develop over the years of undergraduate study? And we're looking at science or subject matter knowledge, SMK, of the content to be taught at their intended grade level in science subjects, and then also their knowledge of students' misconceptions that will typically be encountered in their teaching. And then finally, we're looking for what factors in high school and college affect pre-service science teachers' science teacher identity once they finally are transitioning into the classroom and taking on their own teaching service. Next slide. So I see several familiar faces here. Thank you to those who participated. How did we go about finding people to participate in our study, and where did we draw from? We used the NCES and searched through that. We were looking for four-year schools, specific teacher education programs, and preferably bachelor's degree programs. We did get a few master's programs, but the majority of them we wanted and did get were bachelor's degree programs. We particularly were interested in speaking with methods courses instructors. And as most of you know, there are all kinds of methods instructors, specific science education methods, general methods, elementary, middle, or high school, grade level methods. And we wanted those to be part of a teacher education program. Sometimes they're removed from that and taught by a content area professor. And we also worked with some of those as well. Where did we find you all? We looked at, oops, back up one, please. We looked at science teaching organizations. We looked at science teacher educator organizations, and we also looked at NARST. Okay. So this is what we had as part of our study. We contacted approximately over 600 individual professors. 158 of them agreed to participate in the study. that came from 154 institutions. The number of instructors that actually ended up participating were 131 instructors, and we had 115 classes. We had initially student numbers, but then I didn't get student numbers. People only reported the number of classes that they had. And then finally, we had 121 institutions that actually participated. And we collected that data over 3 semesters, from fall of 2021 through fall of 2022. We had repeat professors participating again with a different class, a new class. And we had some duplicate schools and duplicate professors, but depending on the class, whether the class was offered or not. And again, as I said, it's a different class when they repeated participation. So we had a total of 62 unique institutions participating, and we had 1,717 student surveys that were returned. Next slide. And this is what that looked like across the country. We contacted a lot of people. Yes, there's gaps here, but we had a good concentration, again, for 62 unique institutions, and completed surveys, returned surveys from students was over 1,700. So next slide. So what does our data set look like? We asked students to complete a survey with questions about their pathway to pre-service teacher education. And that included demographic questions, their high school experiences, college experiences, what their intended and expected degree would be, what certifications they hoped to have, what content areas they were looking to teach, and also what grade level they wanted to teach those content areas. We also asked them about science teacher identity. And then we did something unique. We asked them to take a content test. So next slide, won't you? And that's what these looked like. The science content tests that they could choose from at the 3 different grade levels: elementary, middle, and high school. And you see that they're earth, life, physical, and space science. And in high school, physical science is broken down to chemistry and physics. Next slide. So what did our sample look like? And this is a pretty good snapshot of the pre-service teacher cohort that's out there. Again, we collected data from 3 semesters. The total number of student surveys was over 1,700. Our sample, and this is largely reflective of the pre-service teacher community, is overwhelmingly female. 76% of those completing our surveys were female, 10.6% male, and then we had prefer not to say or prefer to self-identify. Again, it's overwhelmingly white. 69.2% of the pre-service teacher candidates in our survey were white. 6.8% are Hispanic, 6.2% Black, 1.7% Asian, and then we also had other that people preferred to self-describe or mixed race. The majority of the students completing these were seniors, because that's where you find your method students, 48.3%. We did have a fair number of juniors, and we also had a couple sophomore and freshmen that were in there as well. Overwhelmingly, the majority of our sample wanted to teach elementary level, and that was followed by middle school and high school levels with similar numbers to each other, middle and high school. But approximately a third of the students that completed our surveys did not know what level they wanted to teach yet. Next slide. So at this point, I'm going to hand it over to Raju to get to the meat of the webinar, the importance of the study and pre-service science teacher identity.
Yeah, thank you, Gerhard. Thank you, Cindy. Thank you to our wonderful research team. I'm Rongxiu. I'm one of the postdoc fellow working at the Science Education Department at the Harvard Smithsonian Center. I will share some of the findings that I have got so far with you all. So why, first of all, why is there a necessity to conduct this study? There are like 2 reasons here. First, developing pre-service science teacher identity is crucial for helping them build stronger personal connections to science and gain confidence to teach science in their classrooms. Secondly, coursework, students' teaching experiences, and out-of-school experiences in both high school and college provide the essential opportunities for pre-service teachers to develop their science teacher identity. So given the importance of having high pre-service teachers, science teacher identity, and the significant effects of high school as well as college experiences in pre-service teachers, science teacher identity, we have developed 3 research questions in this study. So first, the research question is, what are the high school experiences that affect pre-service teachers, science teacher identity? Secondly, what are the college experiences that affect pre-service teachers, science teacher identity? And the third research question is, are there any interactions between the types of pre-service teachers, which are elementary versus middle and high school teachers, and high school and college experience in affecting pre-service teachers' science teacher identity? So the dependent variable we are using is a continuous measure of the statement. I see myself as a science teacher with a 6-point Likert scale ranging from 1, no, not at all, to 6, yes, very much. And to validate this single item as a measure for science teacher identity, we have found this single item is correlated with the following items. For instance, my family sees me as a science teacher. My friends or classmates see me as a science teacher, and I feel confident teaching science. I'm confident about my ability to teach science. Yeah, so here is the plot that shows you how the validation goes of this scale. So as you can see, the 2 items on the top, my friends see me as a science teacher. My family sees me as a science teacher. These 2 load onto the subscale recognition. The middle 3 sub items, science is interesting to me. I enjoy learning about science. I like to know what's going on in science. Loads on the subscale interest. And the below 3 items, I understand concept I have studied in science. I feel comfortable teaching science. I'm confident about my ability to teach science. These 3 items load onto the subscale competence or recall performance. And all these 3 subscales load onto the latent variable identity. And this latent variable has a high correlation of 0.080 with the observed variable. I see myself as a science teacher. Therefore, we decide to use this one single item, I see myself as a science teacher, as our dependent variable. So besides the dependent variable, we also have a list of independent variables that we are going to test in this study. So for high school variables, overall, we have 21 items that we have tested the correlation between with the pre-service teacher, science teacher identity. It's, for instance, science course taking. It includes physical science course, earth science course, etc. And secondly, we have mathematics course taking, which are statistics and calculus taking in our study. And the third list of the high school variables are out of school time experiences. For instance, some unstructured variables like read, watch STEM on fiction, read, watch STEM related entertainment, as well as talking about science with friends, families, and teachers, etc. And we also have tested variables during college. And overall, we have 66 variables that we have been tested together. For instance, we have tested STEM course-taking course. It includes, for instance, general science, integrated science, earth science, also called geology, space science, astronomy, etc. The second list of college variables are general education course taking. For instance, intro to education, or called foundations of education, intro to science, intro to STEM education, general methods, and science methods, etc. And the third list of college variables that we tested are out of school time experiences. Those are the same variables that we have tested in high school as well. And the fourth list of variables that we tested is the students' teaching experiences. For instance, observation in a classroom, discussion of lessons taught by mentor teachers, etc. So first, let's start with the effects of high school predictors of science teacher identity. So our first question is, does taking STEM courses in high school affect pre-service teachers' science teacher identity? So here the x-axis is the point estimate of regression coefficient for each individual regression model, and the y-axis is the course taken, the courses the pre-service teachers take during high school. So in each regression model, we control for gender and race and ethnicity. So as you can see in this the results showed pre-service teacher who take chemistry and physics showed a statistically positive effect in predicting their science teacher identity. With controlling for gender and race and ethnicity in each model. And our second question to be answered is, does taking mathematics course in high school affect pre-service teachers' science teacher identity? So the variable calculus here is calculus and statistics are dichotomous variables. So so it refers to students who take any kind of calculus course or statistics course. So students taking any kind of the calculus course will be counted as 1, and students who take any kind of students who did not take any kind of calculus course will be counted as 0. And similar coding methods is for statistics as well. And so you can see from this figure, students who take calculus showed a statistically positive effect in predicting their science teacher identity, while statistics does not show the significant effect there. This is our third research question. Does having out-of-school time experiences in high school affect pre-service teacher, science teacher identity? So we have tested using 14 items overall. Some items are structured, some items are unstructured, some items are like opportunities that students can take in their out of school time. So as you can see, all of the items show positive effect except for using education materials or resources. And from the top to bottom, it's ranked by the higher coefficients to the lower coefficients. So so from the figure, you can see like students talk about taking some unstructured activities, such as talking about STEM with friends, talking about STEM with families, or even with those with opposing views, showed quite high effects in predicting their science teacher identity. And also, students who take part in some structured STEM-related extracurricular clubs or teams also showed quite high positive effects in predicting their science teacher identity. And to have a more comprehensive understanding of the effect of this model and have a bigger picture of the effects, we have also conducted the multiple regression with all the variables together in one model. So here we have, due to the high cardinality, we have collapsed a few variables into one variable. As you can see in the out of school time experiences block here, we have collapsed the read, watch, STEM nonfiction and read, watch, STEM entertainment variable into one composite variable here, and take STEM related out of school time activities. We have collapsed the take part in STEM related extracurricular clubs, teams, attend STEM events, programs, attend OST STEM related lectures or talks, and take OST STEM related courses or workshops. Because of the high cardinality among this four variables, we have also collapsed these variables together into one composite variable, take STEM-related OST activities. Also, the talking about STEM-related variables here, talk about STEM with family, with friends, and those with opposing views. We have collapsed that into one composite variables. So as you can see from this big table, STEM students, STEM course taking chemistry and physics chemistry course and the calculus course taking and the taking STEM related OST activities, and think about how science can explain my everyday experiences, as well as talking about STEM with family, friends, and those with opposing views, showed positive effects in predicting the science teacher identity, with controlling the gender and race ethnicity in the comprehensive model. And the whole model explains about like 15% of the variance in explaining science teacher identity. So here is a kind of a summary of the significant positive effects and the significant negative effects in this comprehensive model for high school predictors. And the variables has been ranked by their from the high coefficient to the low coefficients in each subset of the model. We have also done the interactions between the teacher types and the significant variables that we have found. So this is one of the interactions that I've found between teacher types and talking about science with the family, friends, and those with the opposing views in predicting science teacher identity. As you can see, talking about science, talking about science is good for every student, and it's increased substantially in science teacher identity for middle and high school teachers. And this is another interaction that we have found between teacher types and thinking about how science can explain everyday life in predicting science teacher identity. So here the thinking about how science can help explain everyday life did not show too much differences for the elementary school teachers, but it showed a huge increase for the middle and high school teachers. Now let's talk about the effects of college predictors of science teacher identity. So similarly, we have also tested a few college STEM courses, the effects of college STEM courses on Preservice teacher science teacher identity. So similarly, the x-axis is the point estimate of regression coefficient, and the y-axis is the courses take the students that the students take. So you can see chemistry, physics, earth science, geology, space science, astronomy, biology, life science. These variables shows the positive effect in predicting science teacher identity. The general science, in integrated science, mathematics, science, statistics, these two variables, since you can see the positive coefficients here, so it showed positive effect, but just did not show significant positive effects in the individual regression model. And we have controlled for gender and race and ethnicity in each regression model. The next question we asked in for the college is does taking education courses in college affect pre-service teacher science teacher identity? And we have 5 education courses in college: science methods, general methods, independent study, introduction to science, STEM education, as well as introduction to education foundations of education. And you can see from the figure, all the general education courses shows the positive effect in predicting pre-service teacher, science teacher identity in our individual regression model. And the science methods and general methods course showed the strongest effect on the top. The next question we ask for the college is, does having out-of-school time experience in college affect pre-service teachers' science teacher identity? And here, the 14 items are exactly the same one for what we tested during high school. We just tested the different effects for both high school and college. And you can see all of these variables showed positive effects, especially the talking about STEM with friends, with families, and even with those with opposing views. Those showed quite strong effects on the top. And also variables like thinking about how science can explain my everyday experiences. This variable also showed quite strong effects on top of the figure here. The next question we ask is, do teaching experiences in college affect pre-service teachers' science teacher identity? And we have tested 10 teaching experiences that students might have during college. Plan a lesson, discuss your own teaching experiences with others, interact directly with students during a lesson, etc. So all of this teaching experiences individually shows the effect in predicting their science teacher identity with controlling for gender and race and ethnicity. We have also done a comprehensive multiple regression model to examine the effects, interactive effects for all of the variables during college. So this is the yeah, we have 2 pages to show the results. So we have STEM course taking, general education course taking, and out of school time experiences and the teaching experiences variables all together in one model. So yeah, as you can see, STEM course taking, earth science, geology, chemistry, and the general education course taking, intro to science, STEM education, and science methods, and out of school time experiences such as follow STEM on social media. Think about how science can explain my everyday experiences. Talk about STEM with family, friends, and those with opposing views, and tutor in a STEM content area. All these variables showed positive effect in predicting the pre-service teacher, science teacher identity. Yeah, and in this model, we also collect some variables that similarly with as what we did for the high school model. And for instance, as I just said, the take part in STEM related extracurricular clubs teams, those 4 items have been collapsed into one. And for the teaching experience variables, we have collapsed that into 3 subsets based on the collinearity and the factor analysis. So we have grouped these 10 items into 3. The first subset is in classroom collaborative teaching. For instance, observation in a classroom, discuss lessons taught by mentor teachers, plan, discuss lessons taught by you with mentor teachers, etc. And the in classroom solo teaching, like for instance, teach a lesson on your own, plan a lesson, and discuss your own teaching experience with others. And the third subset is taking part in a non-traditional field experience. So these variables we tested both in like dichotomously, whether they take it or not, as well as how many times did the student take. So the result showed similarly for both approach. Therefore, we decided to just apply the dummy approach in this comprehensive model. Yeah. And this model explains for 24% variance in explaining these variables explained for 24 variance in explaining the model. And here is the short summary of this positive effects in the college science teacher identity model. And I also rank that by the high coefficients to the low coefficients in each subset of the model. So besides the interaction we have found in high school, we have also conducted the interaction between teacher types and some significant variables that we have found in predicting the science teacher identity. And we have found two significant interaction effects. This is the first one. So we have found a significant effect between teacher types and attending STEM-related clubs, events, lectures, courses, workshops in predicting science teacher identity in college. So here you can notice that the attending STEM-related clubs, events, lectures, courses, workshops, this series of activities did not show too much differences for the student who do this or who do not do this for elementary school teachers, but it showed a big increase for the middle and high school teachers. Another interaction we have found between the teacher types and thinking about how science can explain my everyday experiences in predicting the science teacher identity. So yeah, so you can see thinking about how science can explain my everyday experiences helps both the elementary as well as middle and high school teachers. And the effects showed more substantially for the middle and high school teachers here. Besides all the simple regression and multiple regression results that we have found, we have also conducted a R-square changed in different models. So this one shows the R-square change after dropping some significant variables during high school. So the left part is the overall model that I just showed to you all. All these variables explained about 15% variance in explaining our science teacher identity, and we have tested the R-square change after dropping each significant subset of the variables. For instance, the top one, we have tested the R-square change after we dropping the significant OST activities that we have found. So it showed the after we dropped those significant OST activities, the R-square changed from 15% to 9%. And the second circle here showed that if we take and then we put back the significant OST variables into the model, and then we dropped another subset of significant STEM course taking variables in the model, which is chemistry that we have found statistically in the model, and the R squared changed from the 15% to 14%. And the last one, and then we put back all the OST and STEM course taking variables again back into the model, and then we dropped the mathematics course taking, which is calculus in our model, and we have found the R squared changed from the 15% still to the 14%. So after calculation, we can see the significant OST activities is about 5.7 times, more than 5 times as the STEM course taking or mathematics course taking in explaining the variance in science teacher identity during high school. And this is another R squared change that we have conducted for college significant variables. So the left side, as I just show you in the comprehensive model, the R squared is 24% in explaining the overall model. And first of all, we dropped the significant OST activities, and the R squared decreased kind of hugely from the 24% to 18% in this model. And then we put back the significant OST activity and dropped the STEM course taking, the significant STEM course taking variables. And in our case, it is chemistry and earth science geology course. And you can see the R squared changed from 24% to 20% in this model. And the last model is we put back all the significant OST activities as well as the STEM course taking variables, and we dropped the general education course taking, and which is science methods and intro to science courses that we found significant in our model. And you can see the R squared changed from 24% to 22%. So after some basic calculation, and we have found in this college model, significant OST activities is approximately 3 times as the general education course taking in explaining the variance in science teacher identity during college, and about 1.5 times as the STEM course taking in explaining the variance in science teacher identity. Yeah, so I think these two plots overall is a big takeaway for every of us. It shows the importance of the OST the out of school time activities in predicting the science teacher identity. Yeah, that's about all that I can share today. Thank you, Cindy. I turn it over to you.
Thanks, Ranju. And for people who are wondering, you can use this QR code, and also I dropped the link for our Mozart website. You can find the pre-service teacher assessments on the professional development page if you're interested in the various grade level and content area tests that we have there. And also we will have another tab on the Mozart website for the this study, the pre-service teacher study, and we will share that when we have that up and running. It's still in progress. So the next slide, Raju, please. So thank you everyone for attending, and we can take questions. This is our contact info if you want to get in touch with us. But we have a time for a couple of questions if people want to either raise hand or unmute and ask your question.
Cindy, do you want to
Yes,
bring up the question that was brought up in the chat about the identities between elementary? I mean, Rojo
Yes.
dealt with a bit with the interactions, but maybe there's something more that either she or Gerhard can say about that.
Sure. And Kevin Anderson, this is from you if you want to unmute and ask the question as well. It was wondering if there are some different identities at play that obfuscate things. For instance, seeing oneself as a science person versus seeing oneself as a science teacher. In other words, an elementary teacher might be a science teacher because they have to be and thus see themselves as one, but they really don't see themselves as a science person. Also, assuming elementary teachers are much less likely to have a science teacher identity regardless of other factors. On that, Raju or Gerhard or Sue.
Yeah, okay, let me say something about this. We started out with looking at science persons, like science identity. That's like our has been our interest for a while. In this study, we intentionally went to science teacher identity because we thought this is something that more directly impacts some important things that happen in teachers' lives afterwards. So for if a science teacher has a strong teacher identity, I think that directly predicts what they will do and how long they will last, how happy they will be, and how much science they teach.
Thank you, Gerhard. Any other questions? So as we mentioned at the start of the webinar, we will share the link to this recording with NARS, and they will put it on their YouTube channel that you can access later. And we'll also share the slide set that we presented today. So there's one more question in the chat. How does the learning approach followed during college degree affect identity? Is there any study?
Can you elaborate on that question? The person who asked? Are you asking about our study?
So, Sushma, if you want to unmute and elaborate on your question, feel free.
Hi, I'm Sushma Sadana from India. So I was doing the study in India where we have taken the teachers coming from different learning backgrounds. So some of them were coming from pure sciences and others are coming from hybrid courses. So I was just wondering if there is any study which supports that the teaching approach, your learning approach for the student teacher, does it affect identity ultimately? Hello?
Yeah, I mean, if this is about the pedagogy in those courses, unfortunately, we don't know exactly how the course was taught. We just know the name of the course and that they took it.
I'm referring to two different approaches. Like if a person is studying in biotechnology. So, the approach followed over there would be kind of STEM approach, I would say. And if they are doing BSc biology or BSc chemistry, that will be more of traditional approach. There'll be less of projects and less of real time, real life content. So will it affect the teacher's identity ultimately?
Yeah, that could very well be. That's a good point. We just don't have data to answer that particular question.
We have one other question. Is there a possibility to follow up on how science teacher identity changes over time? And to my knowledge, we don't have that in the pipeline yet, but Gerhard and Sue, you can comment on that.
That would have to be another study. We don't have that data from this. In other studies, we have still, as part of a retrospective survey, we've asked their identity or their perception of their identity at different times in their life. But we didn't do that for this one. We just asked them their current, while they were starting the methods course. The last question, this is interesting. Math and stats in high school have a higher effect on identity, but a lower effect in college. Why do you think this is? Any thoughts on the math? Or Joe, what do you think? Or Gerhard?
Yeah, let me just speculate a bit. We don't know really what's going on, but it might be a difference between math and science. In high school, taking math might be a stronger indicator of being interested in science, whereas in the college, these two areas might have separated more, so that it becomes more important to take science courses rather than mathematics courses. That's just my initial explanation, and that's actually a very good point to point that out. I don't think we even noticed that before, but yeah, that's as far as it goes right now. I think there's a greater differentiation between math and science that goes on in college than it went on in high school.
And a follow-up question to that, I wonder why you use a single item to measure science teacher identity instead of having a separate instrument that can measure the construct in depth.
I can answer that a little bit. This was something that again, the major goals of this study were to look at subject matter knowledge and knowledge of students' misconceptions for teachers. And this identity, we added onto it. It was a component of the study, but it was not the only component of the study. And so we only had so many questions we could ask on a survey. And that's why we actually asked all of these questions on the survey. There were 9 questions. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9.
9.
Right. So we actually did ask 9 questions, but as Rongjo mentioned, we were able to validate a single item, and so we used that as a measure. So
yeah, and a single item measure has, of course, many pragmatic advantages. That you can measure something that's fairly complex and hard to understand, like identity. On just with one question, you don't waste time and space on your questionnaire. So we validated a similar issue on computer science identity, which Rongju has already published, and so this is a good contribution to the field because people can use a single item rather than going through the whole process of validating a complex measure.
Okay, we are right.
move your slide. You're on. your searches on the.
Oh, Raju, you're
Oh.
blocking the slide.
Oh,
So,
I'm
all right.
sorry. Yeah.
We are right at
I just
3
want to
o'clock.
share this single item CS identity measurement paper. I put the link in the chat box. Yeah. If you want to take another look of how we validate that item.
Perfect. Thank you, Raju. So we're right at 3 o'clock, as I mentioned, and we want to thank everybody for attending. It's nice to see some familiar faces of participating professors here as well. So thank you, Raju. Thank you, Gerhard and Sue. And we'll be posting this link to NARS, and you can watch the recording again. Thank you.
Thank you.